Hello everyone, welcome back to my channel. Today we will be doing Unit 2 of June 2024. So let's just get into it. First, we'll be doing the MCQs. So the first MCQ is the enthalpy level diagram for a reaction with an intermediate is shown. Okay, which arrow shows the enthalpy change for this reaction? You know, Del H, enthalpy change is actually change between product minus reactant, right? So it's a difference between product and reactant. If you look into the diagram, we can clearly see that only A is actually giving us this difference between product and reactant. So arrow A is going to be our answer. Sodium chloride dissolves in water to form a solution because of the interaction between sodium chloride and water. What are these interactions? You see the positive ion is interacted with negative oxygen, and the negative ion is interacting with the positive del positive hydrogen. So these are dipoles and these are ions. So it's a dipole ion interaction. See, option C is the answer. Which equation represents the energy for the reaction for which of the enthalpy change del H is mean bond enthalpy of CCl bond in CCl. So mean bond enthalpy itself states that it is the amount of energy required to break 1 mole of gaseous bond. So the main thing is A could be one of the options, but A is not the answer because it is showing that we are breaking 4 covalent bonds. If 1 mole is broken, we need to divide it with 1/4, and we get our option B as the answer, right? Gaseous bonds. It is the bond broken. So automatically C and D is not the answer. Now, question number 4, this question is about boiling temperatures. Which isomer has the highest boiling point? Highest boiling temperature depends on the structure. If the structure is extremely large or the structure is very, very bigger, the molecule that is bigger will have the highest boiling temperature. So the molecule which is the straight chain will have the highest boiling temperature. So answer A. Which compound has the highest boiling temperatures? Again, the boiling temperature depends on the intermolecular force of attraction. A, pentane has only London force. Cyclopentane also has only London force. Butane 1-ol has hydrogen bonding. Butane 1,4 also has hydrogen bonding. But butane 1,4 diol can create two hydrogen bondings because there are two OH bonds in butane 1,4. So it will have the highest boiling point. Steam is passed over heated magnesium. Which reaction occurs most readily? We already know magnesium reacts with steam to produce magnesium oxide. So option A is the answer. What are the products formed when lithium nitrate and calcium nitrate heated separately? Okay, so lithium nitrate and calcium nitrate, both of them will be actually behaving like the same because lithium behaves like the same as group 2 nitrates. So that's why both of them will have the same observations. So we see that lithium oxide, nitrogen dioxide, and oxygen is going to be produced. This is the only option that shows that they have the same observations. So option D is the answer. Group 2 compounds give different colors in a flame test. The best explanation is that the cations have different gaps between energy levels. A is the answer. Because you see, why do we see color? We see color because the electrons, they actually jump to energy level and then again they drop back. When they drop back, they give us some kind of energy, and if that energy frequency has a specific color band, we see that color band. And in every compounds or in every positive ions, we have this gap. This gap differs. So due to this difference in gap, we get different colors. Next, two tests were performed on an unknown ionic compound. Silver nitrate solution was added to aqueous solution of a compound. This is a test for halide, forming a white precipitate. So that's why this shows that this is a chloride. A flame test is observed, a red flame is seen. Now, a red flame is observed for lithium as well as for strontium. So answer has to be between B and D. Since we get a white precipitate, that gives us chloride. So the answer is going to be strontium chloride. Which compound It needs exactly 9 moles of O2 for complete combustion of 1 mole of compound. For this, we have to balance each of these equations first, and then after that, we need to look into. So if we use the first one, C5H12 plus O2 gives us CO2 plus H2O. Let's first write down everything, then we will balance. C6H12O plus O2 gives CO2 plus H2O. C6H14 plus O2 gives CO2 plus H2O. And last, C6H14O plus O2 gives CO2 plus H2O. Now, if we start balancing, 6 carbon, so I need to put a 6 over here, and 14 hydrogen, so 7 over here. 6 twos are 12. 12 plus 7 is 19. One of the oxygen is over here, so 19 minus 1 is 18. To make this 18, I need to put a 9. So, okay, now this came in the first try, so we can clearly see that this is the answer. But even if you try for the first ones, you will see that we are not requiring 9 moles of oxygen to completely react with each of these compounds. So it is a trial-based way that you need to actually find the answer. So it's better that to write down the answers for the ones that you know already very fast, and you can use some of the times into the questions which requires some workings to be done. Which solution remains clear on addition of barium chloride solution? Okay, so barium chloride it's kind of like a test for sulfate. So sulfate, if there is a sulfate ion presence, we will get a white precipitate. But the question asks us whether it is going to be clear or not, right? So right off the bat, option A and D is not the answer because both of them has sulfate ions. Now, sodium nitrate is going to be our answer. B is not the answer because silver is going to react with this chloride ion to produce a white precipitate, silver chloride, which will give us a white precipitate. So the solution will not remain clear. The only answer is C. Next, in a titration, a conical flask containing 10 cm cube of 1 mole per dm cube sodium sulfuric acid is fully neutralized by 25 cm cube of 0.8 mole per dm cube sodium hydroxide. The titration is carried out using methyl orange as an indicator. What would be the color change at the endpoint? You see, sulfuric acid is being neutralized by potassium hydroxide. That means in the conical flask, we already have sulfuric acid, and acid methyl orange has a color red in acid. So starting color will be red. The only option that we can see starting color red is B. So we can directly write down B, right? And later on, we already know that the endpoint methyl orange has a endpoint color orange, so red to orange. What is the concentration in mole per dm cube of potassium sulfate solution produced in this reaction at endpoint? Give two significant figures. So for this, we need to do some calculations. Let's just try to do it right now. So first, we need to find the moles of sulfuric acid. Okay, let's write down the equation first, right? So sulfuric acid is H2SO4 and it reacts with potassium hydroxide, KOH, to give us potassium sulfate, K2SO4, along with H2O. So we can see we need to balance this equation. We need to put a 2 in front and over 2. So the ratio is 1:2. If we find the moles of H2O, if we find the moles of this, moles of sulfuric acid is going to be 10 times 1. Since it is in cm cube, we need to divide it with 1000. And the answer is going to be 0.01 mole. For potassium hydroxide, the moles is going to be 25 times 0.8 over 1000. That gives us 0.02. So the ratio is, you see, 0.1 mole reacting with 0.2, which is kind of like the same. None of it is actually excess or something. So according to this, the moles that we are going to get for sulfuric acid is 1:1 with sulfuric acid. So sulfuric acid has a mole of 0.01. We will get a moles of potassium sulfate as 0.01, right? So they are asking us to find the concentration of 0.01. So if I find the concentration is equals to moles time moles times 1000 over total volume. So you see, what is the total volume over here? It is 10 plus 25. So 10 plus 25. This will give us, okay, let's not write it down over here. Let's write it over here. This will give us 0.8. Okay, let me shorten it out. 0.85. So that is going to be 0.29 mole per dm cube. Do we have an option for 0.29? Yes, we have, which is C, right? So C is the answer. Next, information about the uncertainties in each reading used to measure the volumes of the solutions in this titration is shown. Okay, sulfuric acid, pipette, and this one, and burette, this one. Okay, which statement is true? For this, let's just try to find out the uncertainties of these ones individually, right? So if you want to do that, what do we need to do? So we use pipette for sulfuric acid. If you remember, the volume of sulfuric acid was 10. So percentage uncertainty will be 0.04, that's the uncertainty, over the volume that we are measuring times 100. This will give us 0.4. So this is 0.4%. For burette, we measured the volume 25. Net uncertainty is 0.05. We need to multiply it with 2 because while measuring using burette, we measure twice because we have the initial rating measure and the final measure, right? So if we do that, okay, so this is wrong for some weird reason. Let's just cut everything out and do it again. This is 0.05 times 2 over 25 times 100, which gives us 0.4 again. So we can clearly see that both of the percentage uncertainty is equal. So the first statement is correctly wrong. None of them are more than 1. The percentage uncertainty of volume of sulfuric acid is 0.8, which we clearly see is not correct. The total percentage of uncertainty is 0.8, which is correct because 0.4 plus 0.4 is 0.8. So the total percentage uncertainty is 0.8. That is the answer. Okay. Next, 12, the boiling temperatures of halogens increases down group 7 because on descending the group, the number of electrons in the molecule increases. The answer is D. Why? Because as we are going down the group, the size of the atom increases. And when the size of the atom increases, their electron number also increases. And since they have only London force depends on the number of electrons the molecule has. So more the number of electron, the stronger the London force, and the boiling temperature is going to increase. Bromine and chlorine each have two stable isotopes. Okay, the isotopes are given. Which statement is true? The atomic radius of Br and Br, both of them are the same. So they are going to be the same. This is wrong. The electronegativity, the atom itself is the same. So electronegativity is also going to be the same. The first ionization energy of Cl is greater than that of Br, which is true because as we go down, the ionization energy decreases. So obviously, chlorine will have a greater first ionization energy than bromine. The answer is C. Cyclohexane density is given. The aqueous iodine layer are shaken and left. What colors are shown? Okay, you need to first understand that aqueous iodine has a color yellow, and iodine in cyclohexane, the color is purple. Now, the density, as you can see, is this one, which is greater, which will be at the lower layer. So lower layer yellow, we have two options, B and C, but the upper layer is going to be purple. The only option is B, which is yellow and purple. Question number 14, 4 containers of the same dimensions holds samples of a gas. Okay, Maxwell-Boltzmann diagram is given. For container 2, the temperature is increased. For which values would the energy value change? Okay, for the energy value, first of all, if you increase the temperature, the graph kind of like shifts to be in like this. It kind of like looks like this. So you can clearly see that your E mode, E mean, and EA are not going to change. It will still remain the same. But E mode and E mean is going to change because the graph shifts to the right side, right? So E mode and E only, which is C. Then for container 3, the same temperature as container 1, the pressure is lower, for which value the number of particles at that value changes. Okay, if the pressure is lower, that means the volume has been increased. If the volume is increased, that means in a fixed space, the number of particles actually changed, right? So if the number of particles actually changed, uh, our both, the answer is going to be, I guess, both E mode and E mean along with EA is going to change. So all of them are going to actually change. D, just because there are different fewer number of particles in a given volume. Okay. Okay. For container 4, at the same temperature and pressure at container 1, the walls of the container act as a catalyst for the activation for the reaction. Okay, so it acts as a catalyst. That means the only value that is going to change is EA. So the activation energy will be changing. So this is it for the MCQs. I will be recording another video which will be covering the section section B and section C as well. So see you in the next one.